Air conditioning systems today use less refrigerant than ever before, yet still face many of the same challenges. These high-efficiency systems require precise testing and assessment be made in order to ensure that your customer stays cool and comfortable. And it all starts with performing an AC performance test, the subject of today's Service Done Right. Today's Service Done Right is brought to you by Advanced Professional. Professional quality parts, service, and solutions dedicated to your shop. Go to www.my.advancedpro.com to learn more. By the time you're first seeing this video, it's right in the middle of air conditioning season for most of the country. And many of our customers are showing up at our doors with the complaint that the AC isn't blowing cold. How do you validate their concern? When I'm faced with this concern, the first thing I do as I bring the vehicle into the shop is to verify the operation of the various controls. Is the AC operating properly? Do the mode doors direct airflow where I want it? Then I set the system for maximum cooling, max AC, blower on high speed, and temperature set to full cold. Then I place my hand in front of the center duct to get a quick gauge of just how cold or how warm the air is coming out. Once inside, we'll open up the hood and we'll verify that the AC compressor clutch is indeed engaged. And if that's the case, I'll shut the vehicle down and I'll install my AC manifold pressure gauges, as well as using a tool like this one to measure ambient temperature, relative humidity, and the temperature coming from the center duct inside the vehicle. Now, one test parameter that we're used to looking at when we're assessing the AC system performance is the temperature difference between ambient temperature and what's coming out of the center ducts. But how much really is good enough? If you're old school like I am, we're used to seeing 30+ degrees difference between ambient and duct temperature. But according to many OEMs, on newer vehicles, that difference could only be about 20 degrees and be considered acceptable. How you obtain these temperature readings is also critical to doing a proper assessment of the system's performance. You want to look up in your service information system exactly what test procedures you need to follow according to that vehicle-specific OEM, with some recommending that the doors remain open, others saying the doors should be closed, even where to place the AC climate controls before making any readings or taking any measurements. Also keep in mind that relative humidity is going to have an impact on your readings, as could barometric pressure. You always want to refer to your service information system and look up the specific procedures for the specific vehicle in your bay. And one factor that can make a huge difference is whether the recirculation door is open or closed. Let me show you what I mean. You may have been taught that to do a proper assessment, you need to check ambient temperature in front of the vehicle's condenser, and you need to check interior temperature at the center duct. You'd set your controls at max AC, and depending on where you learned, the doors were left open or closed. So for the purpose of our experiment, we're going to leave the doors closed. When the recirculation door is open, the air entering the system has a full heat load to dissipate. If we compare the temperatures with the ambient reading taken at the condenser, it's close to the same as the temperature we measure when we measure ambient at the fresh air inlet, isn't it? Depending on the year of the vehicle, if we get a 20 to 30 degree temperature change here, it's an indication the AC system is doing a pretty good job of taking on that heat load. But what happens if we close the recirculation door? Now, compared to my ambient reading, the difference is significant. Now we have a 50 degree drop in temperature. But does that mean the system is working any better? Well, sort of. The air entering the evaporator core with the recirculation door closed is losing some of its heat load on every pass. So the next time around, the system is able to absorb a little bit more. To more accurately assess the ability of the system to absorb the heat load, we need to reference our ambient temperature reading to the air that's actually entering the evaporator housing. So let's see what happens when we reference our ambient temperature reading to the temperature of the air actually entering the evaporator housing with the recirculation door closed. As you can see, the difference is close to the same as we saw when the recirculation door was open and we were referencing outside air temperature. The key is that both temperature comparisons are providing an indication of just how well the system is removing the heat load. This is the 20 or 30 degree difference that I mentioned at the beginning. So if you're still using this old school technique, remember it's critical to where you're referencing your ambient air temperature relative to the position of that recirculation door. Better still, take the time to look up the test procedure specific to the vehicle in your bay and follow it for a true professional assessment of your customer's air conditioning system. And if an AC repair is warranted, be sure to visit our sponsor, Advanced Professional, by going to my.advancedpro.com. And I also encourage you to check out the training resources offered by the Advanced team, the CarQuest Technical Institute and the WorldPAC Training Institute. Links to these two organizations is in the video description, as is a link directly to the full line of Advanced Professional AC components. Now, I appreciate you taking the time to watch. That's service done right, and I'll see you next time.